If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in basic level where you are solving previous year Tripura University questions on method of differentiation. So in this lecture we will be solving question number 15, 16, 17, 18 and then 19. Okay, then let's try to solve these questions. Next, if you come to question number 15, if y is equal to this, then again proof. So same type of, but here it is now sin inverse x whole square. So no need to worry, we will do in the same way. And what we have to prove, we will write that proof every time side by side with this y2 minus xy1 plus 4. You have to find this value, not proof. Same type, value means if you can prove this is equal to something, then that will be the value. So if you do differentiating, again you will write differentiating with respect to x. So it will be dy dx is equal to, first you do treating this one as x, something square. So something square is 2 into x. Then you treat differentiation of this one 1 by 1 minus x square. With y there is 1 minus x square, so I will keep it that side. This one I am writing y1. Then you again differentiate. So 1 minus x square differentiation of y1 is y2 plus y1 constant differentiation of this one 2 root 1 minus x square, and 1 minus x square is minus 2x. So it is differentiation of this one. So if you take multiplying both sides by root 1 minus x square, so it will be 1 minus x square y2, then minus 2 get cancelled, x y1 is equal to 2. So what they are asking, this one is okay, minus x y1 is, they are asking plus 4. So you add plus 4 both sides, so your answer is 6. So this is your answer. So this plus 4 will be equal to 6. Next, if you come to 16, again y is equal to given x by x plus 4. What they are asking to prove this one, dx dy1 plus y minus y1 is equal to 0. Okay, so again you write differentiating with respect to x. So dy dx is equal to, this is u by v format, v square, v constant, differentiation of u is 1 minus u constant, that is numerator, differentiation of denominator. So x get cancelled, it is 4 by x plus 4 whole square. So because it is of first order, no need to do it in like second order, you multiply this one, no need. You put it in the left hand side, you will find the answer is 0. So if you put in LHS, what is your LHS? X y1, this is your y1, x y1 plus y into y minus 1. So this is x into what is y1, 4 by x plus 4 whole square, plus what is y, y is x by x plus 4, what is y minus 1, x by x plus 4 minus 1. So if you do this one, it will be 4x by x plus 4 whole square plus x by x plus 4 into, here it is x plus 4, and then x minus 4. It will be 4x by x plus 4 whole square minus 4x by x plus 4 whole square. So it is 0. That means your RHS, which proves this one. Now if you come to question number 17, sin y is equal to this, then prove this is equal to, okay. So sin y is equal to, again it is implicit form, so you cannot segregate y here, so you directly differentiate. So differentiating with respect to x. So it will be sin differentiation with respect to x. That means you are doing with ddx, that you have to be careful. But it is a function of y. So I will treat it as a x. So first sin, differentiation of sin is cos. Because I am treating it as an x, now I have to differentiate again y. Because I am doing ddy, so dy dx. So ultimately it will be ddx. So here first x constant, differentiation of this one is cos a plus y. Again differentiation of this a plus y will give you 0 plus dy dx, plus sin a plus y is a constant, differentiation of x is 1. So you keep all dy dx in one side, so it will be cos y minus x cos a plus y is equal to sin a plus y. Therefore dy dx is equal to sin a plus y divided by cos y minus x cos a plus y. So here you can see in this proof no x is there, so you eliminate x. So if I want to, because it is proof, you have to complete it, otherwise if they ask you find dy dx, then this is your answer, no problem, you can keep it as an answer. But they are asking to prove this one, so I have to bring this one. To bring this one, you can see no x is there, so you eliminate this x. So from here if you calculate your x, what will be your x is equal to sin y divided by sin a plus y. So I will put this one here. It will be sin y divided by sin a plus y into cos a plus y. Now if you take sin a plus y as an LCM, so this sin a plus y will go up, so it will be sin square a plus y, and in the denominator it will be sin a plus y cos y minus cos a plus y sin y. We can see in the denominator it is forming sin a cos b minus cos a sin b, that is sin a minus b. So a plus y minus y. So it is proved. Sine square a plus y divided by sine a. Now in 18 they are asking to find dy dx when y is equal to this. So they are given y is equal to tan inverse cos x by 1 plus sin x, and to find dy dx. So you can directly start doing dy dx, taking this one as a tan inverse to applying that formula, but that will take some time. If you can simplify it one, that will be helpful for you. So this special type you can remember it because it is a very special pattern, cos x 1 plus sin x. This will be also useful for your integration and other applications. So this cos x, actually what we do, you write cos to theta, that is cos square x by 2 minus sin square x by 2, and this one we write cos square x by 2 plus sin square x by 2, sin square theta plus cos square theta, and this sin 2 theta is 2 sin x by 2 cos x by 2. So what it give rise to? Tan inverse. In the numerator it is cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2, a square minus b square, and the denominator is a square plus 2ab plus b square. So it gives cos x by 2 plus sin x by 2 whole square. So these and these get cancelled. So ultimately you are left with cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2. So you divide numerator denominator by cos x by 2. So it will be tan inverse. If you divide by cos x by 2, it will be 1. Sin by cos, it will be tan x by 2. It is 1 plus tan x by 2. Now can we apply some formula here? Yes. What is the formula? You can write it tan pi by 4 minus tan x by 2 divided by 1 plus tan pi, because tan 45 is 1. You can put it anywhere so that it becomes a formula, tan a minus b by 1 plus tan a tan b. It is the formula of tan a minus b. Because from inside, if I can bring tan a minus something of tan, so this tan inverse and tan get cancelled, my answer will becomes pi by 4 minus x by 2, which becomes very easy for me. Now if you differentiate dy dx, it will be a single one line step. It will be 0 minus x by 2 will be only equal to half. So that is your answer. If you come to question number 19, find dy dx when x is equal to this, y is equal to this. Is parametric format. So x is equal to a theta plus sin theta, y is equal to a 1 minus cos theta. So if they ask you to find dy dx, what we do? Dy d theta divided by dx d theta, because there is no direct relation between y and x. So there is a relation by using that theta is the parametric parameter. So you can differentiate y with respect to theta, x with respect to theta. Then if you divide d theta get cancelled. You are getting something of dy dx format. So that is the idea. So if you do dx d theta, a differentiation of theta is 1 with respect to theta is 1, sin theta is cos theta, dy d theta differentiation of a is constant is outside, 1 is 0, cos theta is minus sin theta, so it will be plus sin theta. So your dy dx will be equal to dy d theta, that is a sin theta divided by a into 1 plus cos theta. A get cancelled, so answer is sin theta by 1 plus cos theta. If you like the video, then press the like button and please give your valuable comments in the comment section.